Hi everyone, this is Cyrus from AML. My topic is hierarchical data model. Let us see what is hierarchical data model. First, a link is an association between the preciously two records. A hierarchical database consists of a collection of records which are connected to one another through links. A record is a collection of fields, each of which contains only one data value. The hierarchical model differs from the network model in that the records are organized as collection of trees rather than as a algebraic graphs. Here, if we see in the hierarchical database, the two records are linked by using a line and consisting of a collection of records. Database means it's a collection of records which are connected by using the links. Here, a record is a collection of fields. Collection of fields means that is attributes. So each contains only one value. Each attribute contains the only one value in that. Hierarchical model different from it. It is very different from the network model. So in the network model, it will organize in the manner of a tree, but hierarchical model is in the arbitrary graphs. First, let's see what is tree structure diagrams. This schema for a hierarchical database consists of boxes which correspond to record type, lines which correspond to links. Means here the how the schema will be there in the tree structure diagram means we have the two things here, boxes and lines. Boxes represent the record types and the lines represent the link between the two record types. Record types are organized in the form of rooted trees, no cycle in the underlying graph. No cycle in the underlying graph. Relationship formed in the graph must be such that only one to many or one to one relationship exists between parent and a child. Here there should be no underlying no cycle should be in the underlying graph, and also the relation should be one to one or one to many relationship between the parent and a child. There should not be a many to many and many to one. It is only one to many and one to one relation should be there in the tree structure diagram. General structure of the tree structure diagram is here we can see A. A is the parent node for the B1, B2, Bn. Here this box represents the record type and this line represents the link between the parent and the child. A parent may have an arrow point to a child, but a child must have an arrow point to its parent. This means here the parent, the child should be always should be pointed to its parent. Here you can see this is the B1 is the child of A. So B1 is point out to the A. Here B2 is child of A. So B2 is point out to the A. They may or may not be there from parent to child, but there must should contain from child to its parent. Here you can see here the link is between parent and child from the child to its parent, not from parent to its child. So this relation should be exist in the tree structure model. This is the general structure of the tree structure. Tree structure diagram. Database schema is represented as a collection of tree structure diagram. Single instances of a database tree. The root of this tree is a dummy node. The children of that nodes are actual instances of the appropriate record type. When transforming here diagram to corresponding tree structure diagram, we must ensure that the resulting diagrams are in the form of rooted trees. That means rooted tree means that root value, whatever the root node is there, that should be have the dummy nodes, right? It should have the dummy nodes. Single relationship. Here you can see customer and accountant. There is a relation that is depositor. This is the year diagram. For that, we have drawn the tree structure diagram. It is here diagram is converted into tree structure diagram. Customer has a customer name, customer street, customer city. Here you can see accountant should have account number and balance. Accountant number and balance. What is the entity here? Account. Here the customer has three attributes. That is customer name, customer city, customer street. This is here diagram is converted into tree structure diagram. Example, here diagram with two entity sets customer and account related through a binary one-to-many relationship depositor. Corresponding tree structure diagram has the record type customer with three fields customer name, customer street and customer city. The record type accountant with two fields account number and balance. The link deposited with an arrow pointed to customer. If the relation deposit is 1-to-1, then the link deposit has two arrows. Here, the link deposit has two arrows. Here we can see two arrows. Only one-to-many and one-to-one relationship can be directly represented in the hierarchical model. As we have discussed earlier, there should be only the one-to-one relationship or one-to-many relationship. Mapping hierarchies to files. Implementation of hierarchical database not use parent to child pointers. Since this pointer requires the use of variable length records, can use leftmost child and next sibling pointer, which allows each record to contain exactly two pointers. The leftmost child pointers point to one child. The next sibling pointer point to another child of the same parent. Here you can see implementation. This pointing to its this record, this pointing to its this record, this pointing to this, and here this is pointing to next record, and hierarchically it is pointing to its child. Not here we have it is pointing to two siblings here, this one and this one. This is the implementation of hierarchies to file. In general, the final child of its parent has no next sibling. Rather than setting the next sibling file to null, place a pointer or pre-ordered thread that points to the next record in pre-order. Using pre-ordered threads allows us to process a tree instances in pre-order simply by following pointers. Here you can see next it is pointing to its sibling, it is pointing to its sibling. This is pointing to its this one. Because there is no sibling, there is no child to this last node, so it is pointing to this one. May add a third child to parent pointer, which facilitates the pre-processing of queries and that requires a value for a child record and requests a value from the corresponding parent record. The parent-child relationship within a hierarchy is analog to owner-member relationship within a DBMS set. A one-to-many relation is being represented, stored together. The member and the owner of a set occurrence stored physically close on this the child records and the parent. Such storage allows the sequence of get first, get next, and get next within parent statement to execute with a minimal number of blocks accesses. What are the advantages of the hierarchical model? Let's see. Conceptual simplicity, relationship between the various levels is logically very simple. Hence, database structure becomes very easier to view. Database security is given by DBMS system itself. It has a security by it will given by the DBMS system only. Simply creation, updation, and access. This model is simple to construct with help of pointers, easy to understand, easy to delete and add records in the database using pointers. This is faster and easier data retrieval through the higher level records in the tree structure. Here simply The modifications, whatever the modification or any changes can be there in the faster manner and can update or manipulate the data in a easier manner. Database integrity. There is parent-child association between parent different levels of records in files. Child records is attached with the parent records, which maintains the integrity. Disadvantage. Complex implementation programs and designers need to have knowledge of physical data storage, which may be complex. Difficult to manage any change in a location of data, need change in all application programs that access change data. Data access is restricted by pointer path. Limitations in implementation. It is difficult to implement many-to-many relationship. Query optimization is not possible or possible up to certain extent only. This is a brief introduction brief about the hierarchical model. Thank you.